Good morning. Okay, let us see the topic like basic linear amplifier. What is amplifier? You can define the amplifier as the circuit which output is greater than the input, and linear amplifier means always the output is proportional to the input. Such amplifier is referred as the linear amplifier. Okay, so amplifier means it magnifies the input signal and always the output is proportional to the input. Then you can say the amplifier is referred as the linear amplifier. Let us take one example circuit. So this is the transistor inverter circuit. Transistor inverter circuit with DC biasing, and a signal source is connected at the base. Since it is acts as an inverter means its output is always complement of the input. So that if you observe the inverter characteristics, the diagram shows the inverter characteristics. What is inverter characteristic is, it is the curve between output voltage and input voltage. Usually input voltage on x-axis and output voltage on the y-axis. In inverter case, if the input is very low voltage range, the expected output is at high voltage. Suppose if the input is at high voltage, the expected output is at low voltage range. Okay, so you can observe in this curve, this is the output high level notation and this is the output low level notation. In between high level and low level, the region is referred as transition region. That means if the input voltage is during in this range, the transition region you can observe. Transition means changing the value from logical high to logical low, or low state to high state. With reference to transistor, when the output is logic high means the transistor in half state, that is it operates in the cutoff region. When the output is low value means the transistor operates in the saturation region. But in between cutoff and saturation region is referred as the forward active region. Now let us see the selection of operating point on which region gives linear amplification. In general, for amplification, the operating point in the active region, that to middle of that active region. If it is middle only, you can get the output is exactly same shape with the input. That with the amplified version you can see. Suppose if the operating point is either nearer to cutoff region or nearer to saturation region or in the cutoff or saturations, you can't get linear amplification, you can get the non-linear amplification. That you can observe in the following diagram. So this is the example for the linear amplification. If you observe here, the output is a magnified value, and at every instant of time the output is proportional to the input, except the difference is in phase. Okay, so that is, there is no change in the shape of the signal. That's why it is referred as the linear operation. Suppose if you see the output waveform is like this. Here what happens, in the upper diagram, positive half of the signal, positive part of the signal is removed. Similarly, in the lower diagram, part of the negative waveform is removed. That means this type of operation is referred as the non-linear operation. non-linear operation. Okay, but our expectation is linear amplification. That means there is no change in the shape of the signal, only the change is with reference to magnitude. It is achieved when the operating point of the transistor is in the middle of the active region, then only we can get, right? Here are some notations to understand what type of voltage and currents we can see in the analysis of the circuits. IB, VB, small letter I suffix capital B represents, that is, one is small letter and another one is capital letter. Similarly, in the voltage represents the total instantaneous values. Total means it includes both AC components and DC components. Suppose if you use only capital letters for representing current and voltages, it indicates only DC values. Similarly, small letters are used to indicate the instantaneous AC values. Whereas capital IV suffix B and BE, these notations with reference to CE configuration. That's why the suffixes are like that. These are the notations used for phasor values. Phasor values. Okay, remember in further classes, if I use IB, VBE like this, you need to understand this is the total instantaneous values. Means it includes both DC components and AC components, right? Then let us see the graphical analysis. In case of graphical analysis, let us consider the same transistor inverter circuit, whatever previously noted, the same circuit here once again I am representing. The transistor is NPN transistor in CE configuration, including collector resistor and RB resistor. At the input base, you can observe both DC battery VBB value and AC signal source are connected. First of all, let us see how to draw a load line on the output characteristics. For that, with reference to output loop means collector to emitter loop. Collector to emitter is a closed loop. Here, if you write a KVL, what is KVL equation here? VCC equal to ICRC plus VCE voltage. If I rearrange this equation, that is IC equal to minus 1 by RC into VCE plus VCC. And the above equation I am representing IC. Now this IC equal to minus 1 by RC VCE plus VCC, it is similar to Y equal to MX plus C. Already you know Y equal to MX plus C represent a straight line with the slope M. Therefore, this equation defines a straight line on the output characteristics known as the DC load line. Now see the DC load line representation on the output characteristics like this. These are the output characteristics of CE. On x-axis we have VCE notation, on y-axis IC, collector current. Okay, so this is a line on the characteristics with the slope minus 1 by RC. Previously we have seen with the slope minus 1 by RC. Then the concept of operating point means, that is, the intersection of load line with the characteristic curves is referred as the operating point. For linear amplification, you know that the operating point exactly middle of the load line. Therefore, I am assuming this at the middle portion of the load line. The operating point is this one shown in figure. With reference to operating point, the IC current is referred as ICQ, whereas VC voltage is referred as VCEQ. Okay. Now, after choosing the operating point in the active region, that too exactly at middle on the load line. Now if I apply AC signal for the amplification at the input means at the base, okay, so what happens? Alternating base current flows. Whenever alternating base current flows, alternating current will be flowed. IC equal to beta times of IB, right? Therefore higher magnitude collector current flows. This current produces a voltage drop across RC resistor. Hence you can observe an alternating VCE voltage between collector to emitter. That voltage is considered as the output voltage. Right? This is the graphical analysis for the simple transistor amplifier diagram. Right? Okay. In next class we can see how to develop an AC equivalent circuit for the given circuit. Thank you.